We have investigated parabolas that are mathematically described with something like this, where we just have an x squared and a y over here and then 4p. And when we're given this type of parabola, this equation right here tells us that the vertex is 0, 0. And we are given the p here so that we know how to find the focus and the directrix. But we can kind of think of this as a parent function. And we can say, okay, what we know about finding the vertex, the focus, and the directrix, how can we apply that to something that looks like this? In other words, something that has a horizontal shift and a vertical shift. Well, first of all, the vertex. Normally, the vertex is at 0, 0. The x-coordinate is 0. However, we've had a shift here in the horizontal direction. And we've also had a shift in the vertical direction. So the x and the y are no longer 0, 0, but they are hk. We get the h, the x-coordinate, from the parentheses with the x, only the opposite. The y-coordinate from the parentheses with the y, only the opposite. Now, as far as the axis of symmetry, it's just going to be x equals h, like usual. Normally, if it were 0, 0, it would be x equals 0, but it's still h is equal to the x-coordinate. And this is for parabola opening up, like we're looking at here. Now, as far as the focus goes, from the vertex, we're going to go up p units up, right? Vertical. In other words, I'm going to add to the k. To get to the directrix, we go down from the k. K minus p. And there's how we get the 4 parts, and the graph might look something like this. Now let's suppose we have a negative in there. Let's suppose it's x squared equals negative 4py. Well, let's think about a shift that's taken place. So here we've got this. So now we've got an upside down parabola that's been shifted. Well, the vertex is going to be the same. It doesn't matter if the parabola is right side up or upside down, right? This parabola opens downward. So the vertex is still hk, and the axis of symmetry is still the same as it was over here. But what changes is when we find the focus and the vertex, because now if we have a parabola opening downward, to get to the focus, we're going to have to go down from the vertex. In other words, I'm going to say k minus p to get to the focus. See, over here it was k plus p. Now it's k minus p. And then to get to the directrix, I go up. So we might have something that looks like this. Now, these two examples here, these are just generalizations of what happens when we have a parabola opening up, like over here, or down over here. Now let's see what happens when we have something like this. Now we have a parabola opening to the right, and the vertex is 0, 0. And what happens when we start applying shifts, vertical and horizontal, to this thing? In other words, what happens when we have something that looks like this? Well, to find the vertex, we proceed the same way as always. The x-coordinate comes from the parentheses with the x, only the opposite. The y-coordinate comes from the parentheses with the y, only the opposite. Yeah. Now, because this parabola is opening to the right, the axis of symmetry is going to be y equals k. See, y equals k, like right here. Okay? Okay, so we're dealing with the y component, the second component. Now, as far as the focus, well, now to get to the focus, we're moving to the right instead of up and down. So what we're going to do is add p to the h. And then to get to the directrix, we move to the left. So we have this line, this vertical line, x equals h minus p, and we get a graph that looks something like this. Now, what happens if we have a parabola with a negative, or an expression with a negative in it, like this one? Well, Then we have a parabola opening to the left. And we want to see, well, how do we deal with shifts when we have this going on? Well, the vertex, the same as always, HK. Then we've got the axis of symmetry, which is y equals k, just like before. Nothing's changed here. But now, look at this. To get the focus, from the vertex, we're going to move to the left. We're going to subtract p. And then to get to the directrix, we're going to add p, and we get something that looks like this. So, two things. So this is how we read. This is kind of an overview of how we read, glean the pertinent information from mathematical expressions that are given to us in these forms. But what happens when we have a mathematical expression for a parabola that's not in those forms? In other words, let's suppose we have this. This is a mathematical expression for a parabola. And let's suppose we want to find the vertex, we want to find the focus, and we want to find the directrix. But this is not a form that we recognize. Well, here's the way we proceed. We're going to use this powerful tool that we have of completing the square. So here's the way we proceed. I'm going to group my x terms together. See, I've got x squared minus 2x, and I move everything else to the other side of the equation. And what I'm going to do is I'm going to take half of this x term, the x coefficient, see, 1/2 of it. And then I square that and add it over here. Well, when I add it to this side, I can't do that without adding to this side as well. So I added a 1 here and a 1 here. Now, when I do that, this little process of completing the square makes it so that I can rewrite this side as a perfect square. In other words, this right here, x squared minus 2x plus 1, it factors into x minus 1 times x minus 1, or x minus 1 squared. So here's what we got. Over here, I've got x minus 1 squared, and over here, I've got 4x plus 4. Well, I can factor out that 4. And now look at this. This looks like a form that we're accustomed to. We can immediately get the vertex, right? 1, comma, negative 1. See? X from the parentheses with the x, y from the parentheses with the y, only the opposite signs that you see in there. Then we know this is a parabola that's opening up. So we know how, well, we know how to find the focus, right? To find the focus, and notice p is 1 here, right? This is 4 times 1. So to get the focus, we're going to add 1 to this negative 1 right here. See? So we've got our focus. And now our directrix, we subtract 1 from it. So look, we added 1 and we subtracted 1. And here's what the graph looks like. Here's our vertex right here. Here's the focus, and here's the directrix. So we did that by completing the square. We had this mess. We couldn't tell much about anything about the vertex or the focus or any of that. So what we did was we completed the square. And then we got the form that we're most familiar with. Okay, let's look at another one. Here's another one. Now this one, it's different from the previous. The previous, we had an x squared. Now we have a y squared. This one tells us that we're going to be opening left or right instead of up or down. So let's group our y's together. And I'm going to complete the square. I take half of the 6, I square it, and I get 9, so I add that to both sides. Now, once we complete the square, we're guaranteed that I can rewrite this side now as y, and then whatever half was. Whatever this is, that's what goes in there. Y plus 3 squared equals 2x, looks like plus 7. Okay? Okay, we're almost done. Now, what I need to do is I need to factor out this 2. Because remember, we're going for that form where we can easily read the vertex. So that means I'm going to need the parentheses just to have a 1x in there. So I'm going to factor out whatever the coefficient of the x is. Okay, so I did that. I factored out the 2. Now, Once we're at this point, you can easily tell what the vertex is going to be, right? Because you've just got something in here with the x, something in here with the y. Over here, we couldn't. We had 2x. In order to use the form easily that I'm talking about, that we're accustomed to, you just need a 1x inside the parentheses so that you can just read directly what the y-coordinate of the vertex is, what the x-coordinate of the vertex is, whatever the case may be. In this case, the x-coordinate. Okay, now we have another problem here in that we don't have 4 times something. That's, our eye doesn't fall on it. So we have to make it so that we can see, okay, 2 is 4 times what? That way we can identify the p. So remember the trick, just multiply the top and the bottom by 4. See, here's the 2, and all I did was multiply the top and the bottom by 4 and pull one of the 4s underneath the 2. See, there's nothing wrong with just multiplying by 4 over 4. That's like multiplying by 1. So I did that, and then I pulled the 4, one of the 4s under the 2, and I get 1/2 here. So here it is. Now, this is a form that we can relate to, because now, look, we can easily get the vertex. -7/2, -3. There it is. I just get the x-coordinate from the parentheses with the x, the y-coordinate from the parentheses with the y, and we know that p is 1/2. Now, this is a parabola that opens to the right, and we recognize that is the case because it's y squared. So what I'm going to need to do is I'm going to need to add 1/2 to this -7/2. And if I do that, I get -6/2. So I get -3, -3. Now, as far as the directrix goes, I subtract 1/2 from 7/2, and I get -8/2, which is -4. And I get y equals -4. That is my directrix, and this is what the expression looks like. So this is the way we have to approach these expressions that are not in our vertex form. If we want to put them in the vertex form so that we can easily identify the vertex, the focus, and the directrix.